Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
Type certification is like marriage in that you have to pick your battles. There are lots of opportunities for disagreement, and sometimes, fighting on a minor issue, even though you might think you're right, just doesn't make sense in terms of the timeline for certification. Part of it is knowing when to let something go and move on, or when to stand your ground and work through an issue.
Hello, everyone. Welcome back, and thank you for tuning into The Vertical Space. Today, we're speaking with Jim O'Sullivan, VP Regulatory Strategy and Special Projects at Matternet. In case you missed it, Matternet became the first commercial delivery drone manufacturer to receive type certification from the FAA in September of this year, 2022. And this is an important industry milestone because, according to the FAA, operators that want to provide a regular commercial delivery service beyond visual line of sight need to run their operations under a Part 135 air carrier operating license. And this, in turn, requires type-certified drones. So we asked Jim to join us and talk about the drone type certification process, what it looks like, how long it took, all the twists and turns along the way, including the remaining challenge of certifying so-called associated elements, meaning all the parts of the drone system that do not fly, such as the ground control station, the data link, and certain others. We also talk about the commercial drone industry broadly, the state of the market today, and upcoming milestones. And for those of you thinking about starting a drone business, you'll want to hear Jim's advice. As VP of Regulatory Strategy for Matternet, Jim is responsible for Matternet's global aviation regulatory work. As mentioned, he led the certification program that achieved the first standard FAA type certificate for an unmanned aircraft system or electric aircraft broadly. He's also responsible for operational approvals worldwide and represents Matternet on standards bodies, including certain ASTM groups, and most recently, the FAA BVLOS Aviation Rulemaking Committee. Prior to Matternet, Jim was a design engineer on the Stratolaunch jet at Scaled Composites. Other work includes designing electronics for an ROV exploring the seafloor in Antarctica, as well as developing circuit boards and chips for Dish Network, Cisco, and Intel. He's an active FAA licensed commercial pilot with instrument rating and an FAA licensed remote pilot. Enjoy the conversation with Jim after a brief sponsor message. This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. Welcome to the Vertical Space, Jim. Thank you very much for joining us. It's a pleasure
Thanks
to
so
have
much.
you.
Yeah, great to join.
So today we're talking about commercial drones, the overall state of the market, type certification, etc. And so it will be a great discussion, but let's start with our standard opening question. Is there anything that very few in the industry agree with you on?
Yeah, probably that the FAA can be a great partner in the type certification process. I think
All right, you gotta love the brevity.
Yeah.
So you're saying that the FAA has been a great partner.
Yeah. I think a lot of parties perceive the FAA as an obstacle, and they can certainly be that. But I think in the right circumstances, they've really been great to work with and very collaborative.
So Jim, let's talk a little bit more about this. Can you unpack this a little bit? What's the reason why most in the industry think that the FAA is not as collaborative as apparently your experience shows?
Well, probably a couple of reasons. One is I think a lot in the industry have been used to working with, shall I say, the legacy aspects of the FAA, the parts of the regulatory environment that are well established and that is just business as usual. And I think it's probably common there to find FAA personnel who might be less flexible. But in the area of drone certification, I think the FAA has done a great job of putting together a team of staff that are willing to approach this with an open mind, because there's just so much new and the old ways don't always apply. So I think we've reaped the benefits of working with that team of people who have had some good ideas about new ways to do it, and have been willing to hear some of our ideas as well.
Interesting. And so these two cultures within the FAA, which one is dominant and which one is ultimately the decision maker?
I think overall, probably the legacy perspective is dominant, just based on the sheer number of people in the administration. Within the teams who've been working on kind of the frontier regulatory aspects of unmanned aircraft, we've actually had quite good results of working with a great team of people who are willing to entertain new ideas. Occasionally, we've run into FAA staff who haven't quite gotten the memo about the new technology and want to do it the old way, but we've eventually been able to work out a path forward.
So you think that your success with the FAA has more to do with how you approach them and how you speak the language that they understand?
I would also say that type certification is like marriage, in that you have to pick your battles. There are lots of opportunities for disagreement, and sometimes fighting on a minor issue, even though you might think you're right, just doesn't make sense in terms of the timeline for certification. I think part of it is knowing when to let something go and move on, or when to stand your ground and work through an issue.
That's a great analogy. Let's start with high-level discussions about Matternet, about the company, about the industry. So can you give us a 30,000-foot view of Matternet?
Matternet develops the technology and operational knowledge that enables urban and suburban drone delivery. So we provide drone services directly in Europe and elsewhere, and then we work with operational partners in the US, such as UPS Flight Forward. But essentially, we develop the aircraft and associated support equipment, as well as ground infrastructure, such as landing pads and automated robotic landing stations. And finally, the software that just ties it all together.
Hey, Jim. So in 2013, your CEO in a TED Talk talked about really three parts of Matternet, which are really compelling. And it sounds like you defined it the same way. So the Matternet, a network of transportation matter, right? And there's three components: the flying vehicles, the landing stations, and the routing software. Are those still the three fundamentals of Matternet?
Yeah, exactly.
It shows a business vision that's beyond just the vehicle. In other words, you've arranged for your infrastructure, and you've arranged for the network, the routing software. Could you just talk a little bit more about that? Because I think it's a little bit unique to many of the people we talk to, or many of the different drone companies and some of the drone service companies. Talk a little bit more about that vision, and if you could, just describe what's worked best in the last couple of years and what's maybe lagging a little bit.
Yeah, so if you have just an aircraft, it's straightforward to make a delivery between two nodes. That's not too impressive. I mean, it's useful, but where things get really interesting is where you can essentially develop a network system, kind of like the airlines have, where you can move matter from one place to another. Yeah, it can kind of take advantage of the network effect once you have a sufficient number of stations and other ground infrastructure out there. One thing that's been challenging to get to a delivery network is the regulatory hurdles and the cost. And this applies to the US as well as other countries. We had announced not too long ago an opportunity in Abu Dhabi. We're working with the Department of Health there to establish a citywide delivery network, which would be the first realization of that Matternet vision. And we are working towards that.
So when you look at the overall commercial drone market, where do you see the greatest early demand in commercial drone use cases? What use cases promise mass scale in the next 2 to 3 years?
Well, so delivery is one of those use cases that's quite visible and tangible to the average end user. In particular, medical delivery, and then business to consumer, such as what Walmart and Wing are doing. Other good use cases that are pretty approachable are public safety. The uses of drones by the police and fire departments. Those have been gaining traction. And then infrastructure inspection. That's becoming a big one. And not just infrastructure, but also agricultural surveying, mining sites, things of that nature. Infrastructure inspection has been fairly manual up until recently, but certain companies like Skydio are automating that process, making the drones more autonomous. Other companies like American Robotics are developing the drone in a box solution where you can place this system out at a mine or an agricultural site, and the drone will just automatically run surveys every day and collect that data autonomously. So I think those are the early cases for demand.
And if you had to single one out that will be the largest of the four categories in a couple of years, what would you choose?
I think drone delivery is growing at a very rapid pace. It's interesting to see Zipline expanding, Drone Up expanding, as well as Wing expanding into multiple cities, and Matternet's growing as well. From our perspective, even though I'm a bit biased, I think drone delivery is going to probably grow the fastest compared to the other use cases.
So given that demand, can you give us some examples of go-to-market strategies that drone companies use to access this demand? What has worked well and what has not worked so well in the past?
One case that's worked well is kind of the in-house model, such as Amazon or Walmart, using drone delivery to capture new customers or retain existing customers. I think they can fold the economics of the drone delivery into their mainstream business and realize benefits beyond just the purely drone delivery. Realize benefits of, like I said, retaining or attracting customers. Building a standalone drone delivery service, such as Wing, I think that's it'll be interesting to see how the economics of that work out. I think the regulations in the US under which drone delivery must operate are fairly burdensome and add kind of layers of cost and friction. And it'll be interesting to see how that business can scale and become economical.
But if you're making $500 million in 3 years, where's that revenue coming from? What segments, what markets?
Are you referring to Matternet specifically?
Yes.
Yeah, I would say it'd be a mix of medical, B2C delivery revenues, as well as technology sales.
And when you say medical, it's so cool. And if anybody has not seen your website and seen the drones, the pods, and the use case that you describe in your site, it's so compelling. I've had people come to me, probably more so than any other company. They've asked me about, have we talked to Matternet yet? Because they love your messaging. Let's say healthcare, and we say medical healthcare. I mean, essentially, is it not just a really fast courier that's delivering really important either, let's say, blood or tissue samples and or organs?
Yeah, it's a very good question. How do we differentiate ourselves from the couriers? So in addition to speed, the other aspect is predictability. So it's always going to take 12 minutes, regardless of traffic, whereas couriers don't have that ability. They're subject to the traffic. And when you have a fast and predictable way of connecting two sites, you can then figure out ways of re-architecting the business. Perhaps you don't need labs distributed at each clinic. Perhaps you can consolidate labs if you can guarantee that all the samples will get to the main lab in a fixed period of time. Some other really interesting use cases that we've seen in the medical space are transfusion of chemotherapy agents. So one thing that's growing these days is chemotherapy agents that are tailored to the patient, personalized medicine. So these agents must be mixed up in lab, and they have a fairly short shelf life. They need to get into the patient pretty quickly. So drone delivery is an ideal use case to get that medicine from the lab to the transfusion center in a quick and predictable manner, minimizing patient wait time, maximizing the right dose getting to the patient. So we think that's one example of a beautiful use case for drone delivery.
Isn't that cool? So what you're saying is, as personalized, targeted medicine evolves, there is a greater need for labs to be able to put together the right mixture and to be able to deliver it to the person on a timely basis. And you're saying that's generally not done in the office, Jim?
That's right. It's usually done in specialized labs or pharmacies that typically aren't that next to the transfusion center. We've seen that in a couple of hospitals that we work with. So they've just loved the ability to have a fast and predictable way of getting that from where the medicine is made right into the transfusion center.
Boy, talk about a river of cash that you could tap that's maybe will save money, but clearly improve outcomes. If Matternet could tap into that, wow, that's terrific. And Luca, this is one of the areas that one of our guests who is sometimes skeptical of AM has said that there's a very good use case.
Totally. So let's double click on the economics part of it. Jim, you brought it up earlier. Economics of some of these standalone businesses need to be still proven. So to the extent that you can speak to it, what are the main levers or main drivers that impact economics perhaps broadly, but also in case of Matternet's delivery business?
Yeah. I mean, speaking in general, one of the key drivers of cost is people. How many pilots do you need? How many support staff do you need? How many mechanics do you need? So to whatever extent the technology can be automated, and that includes having one pilot operating multiple aircraft. So automation will help drive down the cost of labor, and that's going to require regulatory support, and that's something that'll just happen with time. Also, the regulatory environment for drone delivery, which in the US is Part 135, it's a fairly heavy regime. This is the regulatory regime that we used for jet charter and on-demand cargo operations. It's made for carrying high-value items and people, and the focus is safety, as it should be. We think that a regime that is more tailored to low-risk drones might make more sense in reducing the regulatory friction. Certainly, staff will be one of the key drivers of cost, but also aircraft cost. As volumes scale up, we can reap the rewards of economy of scale and drive the cost of aircraft down, and that will contribute as well. Other forms of technology will help with automation and reducing labor. For example, the robotic landing station that we've talked about. That's a way of doing a couple of things. One is removing the need to have a person receive the aircraft when it lands. That reception can be done by this automated hangar. And it also removes the need for the customer to be there at the same time the delivery happens. The station will store the samples or store the material, keep it cool or warm as appropriate until the customer is ready to come pick it up. So it allows more flexibility there.
What would you say are the remaining points of friction that exist today that prevent mass adoption of commercial drones? Regulation is one, but besides that, is there a certain aspect that end users really care about, but they're not really getting, or it's too difficult, or there's some other hurdles that they need to go through in order to ultimately either stand up a drone fleet of their own or do business with somebody who does that for them as a service?
Yeah, I'd say in addition to the regulatory friction, there are two other elements. One is uptime and service availability. As you know, aviation is subject to weather and mechanical issues, and it's going to take time for this new technology to increase its weather envelope. I would say the other aspect is the complexity of operating safely. I mean, we don't even have mass adoption of aviation. Like, not everyone has a plane in their driveway. I mean, we all can go to the airport and fly on a plane, but in terms of individuals directly operating aircraft, it's still quite uncommon. Aviation is complicated, and safety is of paramount importance. And to stand up a department that can operate a fleet of aircraft safely takes a fair amount of effort and time and resources.
How many drone OEMs do you think will dominate the market in this decade? You think the market is large enough for 5, 10, 15 different OEMs? And is there a gap currently that you see in the market?
Yeah, it's an interesting question. Forecasting the number of platforms that the market can support is going to be really challenging. I think it depends on how fast the market and regulations evolve. I mean, right now, getting an aircraft certified is quite a challenge, and not many organizations have the resources or the abilities to get that done. So I think that alone will limit the number of OEMs that can provide certified aircraft which are required for delivery. Other use cases, such as surveying or inspection, don't necessarily require certification. And so I think we'll see more options there, more options that are tailored towards specific use cases. But putting a number on it's pretty hard to predict.
Mm-hmm. Got it. So, okay, you raise a very interesting point, and let's slowly transition into the type certification process. But first, what determines whether a particular use case needs a type certified drone?
So typically, if the aircraft is fairly heavy, and that can be quantified by kinetic energy. So if you're flying under Part 107, there's a threshold of kinetic energy above which you must be type certified. It's called Category 4 operations. Most camera drones can fit below that, and so don't need to be type certified. If you're doing delivery, particularly if you're doing delivery under BVLOS, that has to be done under Part 135. And Part 135 by law requires a certified aircraft. So far, not just Matternet, but also the other partners that are doing Part 135 cargo ops with drones have been operating under an exemption called the 44807 exemption, which allows you to use an uncertified aircraft under Part 135. That exemption will expire next year, and so type certified aircraft will be required for Part 135 operations.
So it's either you're doing delivery, in which case you need a Part 135, which drives the type cert requirement, or you are above a kinetic energy threshold, and then you need the type certification even if you're under Part 107.
Yes.
And some of the other use cases of infrastructure inspection where you are not necessarily above Category 4, but you are inspecting infrastructure that has a complex ground risk situation. What happens in that scenario?
Well, you just need to comply with the ops over people rule under Part 107, or not operate over people. I mean, generally, when you're inspecting bridges, you can avoid flying over people typically, but it really depends on the specifics of the operation.
And if the ConOps involves beyond visual line of sight?
Yes, interesting topic. So, BV loss is the big elephant in the room for drone flight in the US. That's kind of one of the major unsolved challenges to really scaling. You've probably heard of the BV loss arc that concluded this year and released the final report. It's a very tough problem to solve, particularly addressing the challenge of non-cooperative manned aircraft. And the ARC made some good recommendations to make progress there, and we are eagerly awaiting the FAA's response to that and proposed rules to push that forward.
Another topic to come back to, but I think we really need to jump into the main topic of today's discussion, which is the FAA's type certification process for drones and Matternet's recent award of the type certification. So can you give us first of all, a bit of an overview? What is it and what does it include?
Sure. So it's a mix of providing deliverables and completing tests. The deliverables include things like a ConOps document, a flight manual and a maintenance manual, design documentation of the aircraft. You have to provide a fleet of DNR aircraft for the test program. And you have to provide conformity documentation for that fleet. You need to provide an AE interface spec. AE is associated elements, which is the FAA's name for everything that's not part of the type cert. You have to complete the noise test program and provide a noise test report. You have to complete the flight test program and operational suitability demonstration and write up a test report and submit that. And finally, there's the statement of compliance. So that's the overall DNR process. Sounds easy. Only took us 4 years and 4 months.
So how does that compare to the type certification of other flying vehicles?
The key difference is classic way of type certifying under Part 23 or Part 25 involves a lot of analysis, whereas the DNR process is almost entirely demonstration, just flight test. And the idea there is that they were trying to right size the process to the level of risk inherent in small UAS.
Bunch of questions to ask about the certification. And again, congratulations. So what was certified and what was not? Was it the vehicle, the stations, the software? What were you hoping to get certified that was, and what were you hoping to get certified that was not?
Yeah, it's an interesting topic. So when we started out, the certification boundary encompassed essentially everything that we make, which was the aircraft, the battery pack, the payload box, and then the ground infrastructure as well, the landing pad, battery charger, a few other accessories. Midstream, the FAA reevaluated their policy on that and redefined the type cert envelope to be that which flies. So in our case, that's the aircraft, the battery pack, and the payload box. Everything else that we provided became what they called associated elements, AE, and was taken out of the type cert program. So we were ready to essentially do the full type cert with everything that we make. And there are pluses and minuses of that approach. For example, we use a PC for what we call mission control. It's the situational awareness software that's used to operate the fleet, and it's operated by a remote pilot. So replacing a mouse under the old regime would become a Part 43 maintenance task requiring an A&P mechanic.
Of course.
Which doesn't make a whole lot of sense. On the other hand, the process for certifying that was clear. We knew exactly what we had to do. It was well established. Even though there was this friction of an A&P to swap a mouse, everything was fairly clearly defined and had our expectations pretty clear. Under the new process, AE is pulled out, but the process for getting AE approved is much less clear. It's now handled by the flight standards branch as opposed to the certification branch. So now we have essentially two approval processes. One is the type cert for the aircraft and the portions that fly, so the payload box and the battery pack. And then you have another approvals process for everything else. And that process is still somewhat opaque.
What are the consequences of that decision by the FAA? How does that reflect in operations in the business?
So in the business, like I mentioned, you just added another layer of approvals to go through in an already heavy process. So under 135, if you make a change to the aircraft, you have to get that approved by the certification branch. Once that's approved, that would be given to 135 operator, who then has to get approval from their certificate management team to work in this new change. Now there's an additional layer of approvals, which is if you change the AE, you have to approach flight standards to get that approved. And then it goes to the CMT again. So it added another layer, which just adds friction.
So back to the example of changing a mouse on the PC, how will you deal with this scenario in the future when you need to replace a small part of the associated elements?
The process we would go through, as we understand it, is to work with flight standards and our operator to get that change approved, and then the operator would work with their CMT to work that into their system.
So in order to ultimately conduct operations under Part 135, you need both the aircraft type certification as well as the associated elements certification equivalent. Is that correct?
Yeah. So the associated elements is handled in type cert by the AE interface specification. So you have to specify the interface between the certified portions and the AE that you expect to use. You can do that in two ways. One is you can specify part numbers, like you can say this aircraft, the M2, is approved to operate with our ground station part number X. Or you can actually define the interface, the technical interface that connects the aircraft with the ground control station and allow your operator to choose any compliant ground control station. So you have choices there.
Mm-hmm. So what approach did you guys choose?
So we used the part number approach. Essentially, specified the Matternet ground control station at a certain revision that operates with the type certified version of the aircraft.
Okay, so given that particular part number of all of the associated elements, you don't have the full approval, both type cert as well as the associated element ops approvals to go and conduct Part 135 missions.
It's a little bit more complicated than that. So we have a document that specifies that this collection of associated elements was proven out during type cert testing. But our operators still have to take that document and go to their CMT and get approval to use that, their certificate management team. So if they use exactly what's specified in the document, then the approval will be fairly lightweight. But if they choose to deviate from anything there, such as a newer version of a PC to run the mission control software, that would need to be evaluated by the FAA and additional approvals given.
You mentioned earlier that operations today broadly for 135 are done under the 44807 exemption, which goes away next year. So all of the things that we're now talking about with the associated elements certification, that needs to be done before next year. Is that a fair statement?
Yeah, that's fair.
And you feel confident that we will get there as an industry?
Yeah, I think so. I think we're making progress.
When Matternet submitted the application for the certification process, you were hoping for approval by a given date. When was that date, and how did it differ from when it actually came in?
So we were led to believe that certification would be an 18-month process.
And it turned out to be 4 years?
Yeah.
Right.
The FAA didn't state that, yes, we guaranteed you'll be certified in 18 months. It wasn't as black and white as that. But that was kind of the understanding that we got. But even 2 years ago, in 2020, the FAA was expecting our type cert to be issued that summer. So I think everyone has been surprised at how long it took to finally get through the process.
But it happened. That's cool. And one question we're going to ask in a minute is, what advice would you give to somebody else, right? So one would be patient. But second, in your business plan, you had certain expectations of certification, both on timeline and what would be certified. Once you got the certification, everybody's happy, everybody's, having a party about their certification. But how did your business plan change and your forecasting change based on the actual certification? Were you more optimistic or less? Is there anything you had to pull back based on what was certified and what wasn't?
One thing that was very helpful is that the 44807 exemption took the time pressure off of the certification process in terms of its practical effects. So the 44807 acted as a type cert when operated under Part 135. So there's nothing that we couldn't do with our operational partner, UPS Flight Forward, that we could do with a type cert. So that was certainly beneficial. However, there are, of course, intangible benefits to the type cert, one of which is the signaling aspect. So type certification is a huge signal that the industry is moving towards regularized regulatory handling and is getting ready for scale. I mean, of course, there are other things that are required for scale beyond type cert, but that the industry can now issue type certification, it's a huge signal that we're making substantial progress.
Once the type certification is obtained, what limitations does it typically come with?
In terms of limitations, we didn't have any significant additional limitations on the type cert beyond what was on the 44807. Just one of the standard limitations that are inherent to the DNR process has to do with population density. So when you work through the DNR process, you declare upfront which level of population density out of a table of 6 ranges that you want to target. So we picked our targets to enable our customers and tested towards that. And so we're limited to that population density range until we choose to conduct more testing hours and expand that. And that's common for any DNR type cert.
Okay, so this is interesting. The way to unlock greater population density is only a matter of collecting additional performance data and flight test data, or does it also have an impact on the system design and requirements and the choices for onboard equipment?
Yeah, so there are two things that work into the permitted population density. One of them is how many hours you run through in DNR, and the other is, do you have an ASTM certified parachute on board? So if you have an ASTM compliant parachute on board, you can cut the flight test hours in half.
In the case of the type certification that you went through with the M2, what is the equivalent level of safety compared to other manned aircraft?
That's a very good question, and it's quite hard to answer. The FAA has not published a target level of safety in quantitative aspects so far for low-risk UAS.
So, Jim, how does one reconcile the fact that there is no targeted level of safety? How do we reconcile that with the realities of the air risk and ground risk that these vehicles will be navigating?
Yeah, it's a very good question. So I think one key difference between UAS and crewed aircraft is that we don't have people on board, and the weight of the aircraft is such that ground risk is significantly less than if you had a heavy crewed aircraft that had a critical failure. So when looking at the risk of small UAS, those are kind of the key differences there. You don't have people on board, and the ground risk is much, much, much less than the equivalent manned aircraft.
So unlike in Europe with the EASA and with the SORA framework, the FAA has no requirement for catastrophic failure condition probabilities.
Well, it addresses those through the required number of testing hours for a given population density. So that's the population density has been a fairly rough index of ground risk the FAA uses. And they've moved a bit away from population density into what they call a risk category. But population density remains kind of the key index. Mm-hmm. And their method of addressing equivalent level of safety is to require more and more DNR testing hours for higher population density areas.
But there's no expressed, say, one catastrophic failure condition for every 10,000 or 1,000,000 hours.
Yeah, there's no one authoritative number for that. There's been a lot of discussion about what that number should be by different parts of the FAA and industry. But yeah, I don't think that there's just one definitive number at this point.
Do you think that we will have such a number come out from the FAA?
I think so. I mean, there was talk about that in the BB-LOS ARC, and so it'd be interesting to see what comes out from the rulemaking process.
Mm-hmm. In the DNR process and showing flight experience and performance data, to what extent did Matternet use simulation to collect data, virtual data, or to test certain scenarios for purposes of certification?
For the purpose of certification, none. We used exclusively flight test to demonstrate the aircraft's reliability and capabilities. Mm-hmm. And we certainly used simulation internally to validate our systems, but we didn't use that as evidence for certification.
And what's the FAA stance on using simulated data for certification?
So, we're in discussions with the FAA right now on incorporating improvements into the type design. As you know, technology moves quickly, and we had our type design frozen for a couple of years as part of certification, but inevitably safety and reliability improvements have been made, and we want to fold that into the design. So we're discussing with the FAA on what kind of verification validation we need to do to those changes to fold that into design, and they are open to using analysis and simulation. We haven't yet agreed on how and to what extent, And that's a subject of active discussions.
Where do you think that ultimately the industry lands? Will it be a third or a quarter or half V&V data that might be coming from simulations?
I think it depends on how robust and accurate the simulations are and what's needed to prove that robustness and accuracy to the FAA.
When people see that we're talking to you from Matternet, there's going to be a lot of folks listening from drone companies, from AAM overall, and from investors in these organizations saying, how did you do it? So what advice would you give to others who are trying to replicate your success?
One is that regulatory timelines and outcomes are very difficult to predict. And this presents business risk if your business depends on use cases that don't fall into well-worn regulatory pathways. So that's something that just has to be paid a lot of attention to.
So Jim, one thing you're saying is be very specific about the use case that you're having certified, and some will be easier than others. Is that correct?
Yes, yeah, certainly. For use cases that they can leverage existing regulation, those will be more predictable than use cases that require regulation to change. Is kind of the key lesson there.
Great. So that would be one lesson learned: is be specific and identify use cases that will be easier to certify versus others.
So another thought is hiring. Hiring staff with deep knowledge and experience in legacy aerospace won't be sufficient. In an industry with a fluid and unsettled regulatory environment, you have to know how it's always been done, whether that's type cert or operational cert. But it's also important to have a fresh perspective and be able to find new approaches to certain regulatory challenges. One example is software in certified aircraft. So the legacy answer for ensuring quality and robustness is DO 178. But that level of rigor and cost makes no sense for low risk UAS. So it's important to put together a team that has a deep understanding of 100 years of aviation tradition and how things have been done with classic crewed aircraft, but also to have parts of that team be able to think differently and come up with fresh approaches and not be bound by how it's always been done.
I have to jump on this and follow up. What are some ways to bypassing 178 requirements for software cert for small UAS that you have seen work really, really well?
Well, so one of the key examples is that as part of the means of compliance for the DNR certification program, certainly you can use DO 178, but another means of compliance is to have what they call an industry standard means of tracking software changes. Just about any software company has that, and provided that you have one in place that is effective and documented, that is sufficient for low risk UAS under the DNR certification program.
So clearly, another bit of advice would be is, if there's software involved, make sure the change process is documented and you're disciplined about that. And if you're not, it's going to elongate the certification approval.
Exactly. Yeah.
Jim, can we talk a little bit about the process of obtaining a Part 135 certificate?
Sure. Yeah. So for obtaining a Part 135 certificate for drone operations, a big part of the process is going to be developing your exemptions. Why do you need exemptions? Well, a lot of the rules that apply under Part 135 are oriented towards having people on board. For example, you have to have a fire extinguisher on board. You have to have seatbelts. You have to have your registration certificate on board and other things like that. Well, drones don't have seatbelts. So you have to put together a package of regulations from which you need exemptions and get that approved. And that's typically an 18-month to 2-year process. Some of the other deliverables of a Part 135 include the manuals, the GOM, the General Operating Manual, the General Maintenance Manual. If you're carrying hazmat, you need a will carry program and associated manuals. You have to develop the training program and curriculum for how you fly. Another hard one is you have to hire the management team, and the regulations specify a certain number of years of experience for, say, the chief pilot or the director of maintenance or the director of operations. And in new industry like this, it can be hard to find that level of experience. So yeah, those are kind of the key steps in getting 135.
So all in, it's a 2-3 year process.
Yeah. Mm-hmm. Certainly starting fresh is a long process, but even if you already have a 135 certificate and you just want to add a UAS to that, that's also a long process. That's probably 1 to 1.5 years.
Okay, so let's say we have a Part 135 certificate and we have a type certified drone, and now we're out and building a business and flying some of these delivery use cases. What are the remaining gaps, whether this is technology or operational, to achieve drone operations at scale?
So I would say the biggest single hurdle is getting to BV loss. And really, why BV loss? Why is that so important? Drone delivery isn't that economically viable if you're just going across the street or going to the next block. It really makes sense when you can go a longer distance and see the true benefits of drone delivery. So how do you do that? How do you get beyond visual line of sight? You have to be able to minimize air risk. And in the US, not all aircraft are required to transmit their position via transponder, particularly outside of controlled airspace. So you need a method of detecting manned aircraft. Typically, these days, that's done using visual observers watching the sky. And under the exemptions that have been issued for Amazon and UPS and Wing, those have to watch every 2 miles of airspace. So that the costs for that add up. You have to have people standing out in the field watching the sky and reporting back. That really limits scale. So in order to scale, we have to solve the BV loss problem. To do that would require technology. So there is no effective technology small enough to fit on a small UAS that can effectively detect manned aircraft, uncooperative manned aircraft in all weather conditions. There are some systems like cameras that can detect manned aircraft, but they're fairly expensive and heavy, and they only work in day visual conditions. So technology is a hurdle in getting to BV loss. The industry just has to come up with a combination of regulatory and technical solutions to that before things can really start to scale.
So how do you think that this technology gap gets filled? Do you think that this is a matter of having some clarity in the markets that will attract innovators, or is this fundamentally technological challenges to get this capability at the adequate form factor?
So different ways to solve this. Some aircraft can solve it on board, say via acoustic detect and avoid. This is the method that Zipline is using. And that makes a lot of sense. Other ways are to establish a network of ground-based sensors and share that data. Kind of like when you use a cell phone, you don't have to buy your own cell tower, you just use a shared tower. Same thing for detection of manned aircraft. Municipalities could build out a series of sensors around a city and make that data available to drone users. That probably would make the most sense long term.
What do you think comes first? What's the right order for these solutions? And to what extent does it really depend on the use case, the environment?
Yeah, maybe the right order is you have some public-private partnership that builds out a certain number of areas and proves out the technique and the economic viability of that. And that enables other municipalities or companies to follow that and expand the network. Clearly it makes more sense when the population density is higher because you have more potential customers per given area. Using existing infrastructure is always the best. One example of that is something called ADSB. Within 30 nautical miles of, I think, the 30 largest airports in the US, almost all manned aircraft are required to have an ADSB transponder. That's a great way for drones to be aware of that traffic, but that use has been limited by the fact that it's not perfect. There are certain exemptions from that requirement, such as aircraft that were certified before there were electrical systems. So, Piper Cub, for example. One of the recommendations of BVLOS-ARC was to enable the use of ADSB as not the only detect layer, but a key tool in being aware of manned aircraft. So that would be another way of using existing infrastructure to solve this detect and avoid problem, but it requires regulatory progress.
What's your prediction for the timeline of BVLOS approvals? Obviously, we had the report of the ARC committee come out in March of this year. How will this impact BVLOS waivers or BVLOS operations in the years before the BVLOS rulemaking? And when do you predict that this rulemaking will occur?
So I think that we will see real BVLOS operations on an exception basis, meaning through exemptions or waivers, in the next year. Some of them using ground-based radar, others using this idea of ADSB in the mode CVL. In terms of the regulations coming into place, coming out of the BVLOS ARC, that's a challenge to predict. I would be surprised if we got anything significant on the books within 4 years.
How does everything that we talked about in the context of the FAA, how is that different in Europe with EASA? Is it a more regulatory accommodating environment? Does it only appear to be more regulatorily accommodating?
No, I think the Europeans have certainly been more regulatory accommodating. For example, we have been flying BVLOS over cities on a daily basis since 2017. The reason there is that we worked with the Swiss Aviation Authority on developing a new way of assessing the risk of operations, which eventually became the SORA process, which is a kind of a graduated and progressive way of dealing with air risk and ground risk. And the Swiss were great to work with, enabled us to get flying over cities quite a bit before the US has gotten there.
Jim, Matternet is such a cool company, and I know we talked about it a little bit earlier and what's unique, some of its foundational elements and the like. But what's the outlook for Matternet? Obviously, the certification was critical. You got it. That's exciting. You obviously have a very unique business model. Love the 3 different components. I've noticed that you've partnered with UPS, you've partnered with Swiss Post. I thought it was Swiss Port, but Swiss Post, UPS, Mercedes-Benz. How important have these partnerships been in proving out the use case and, frankly, from a public relations perspective and maybe attracting investors?
Each of those partnerships were very important and pushed us along and helped us in various ways. The partnership with Mercedes-Benz was very interesting in terms of exploring the unification of drones and vehicles. And are there new interesting ways of deploying drone delivery from moving vehicles, or can you come up with a hybrid approach of package delivery where you will drive a delivery truck to a certain location and walk in a package while the drones dispatch and go to other locations to improve overall efficiency of package delivery?
It's like mobile infrastructure, right?
Yeah, exactly. So that
was very cool. That was in MIT Tech Review. That's a really neat approach to infrastructure.
Yeah, it was quite interesting exploring those different possibilities with them. And then the partnership with Swiss Post was very helpful in terms of getting us into the Swiss market and getting us introduced to some key hospitals there and setting up networks there. The one with the UPS, of course, enabled us to fly for revenue commercially in the US, and was, of course, and still is a very visible and great partnership.
In delivering medical supplies in North Carolina.
Yeah, North Carolina and Florida as well.
Delivering prescriptions, to develop lab supplies. You would think that's such an attractive market, as we were talking earlier. And obviously, you would think it's a large market, as long as the economic value is there. But that's awfully exciting. I often think of Matternet as, rather than the vehicle, I think of the use case, where so many others, we think of the vehicle first. So you've done a wonderful job in that respect. Let's say there are a lot of investors in the line right now. What would you say the top 2 or 3 reasons they should be looking at Matternet? If you are raising funds, I have no idea. But what's most attractive from an investment standpoint in Matternet?
Well, one of the key aspects is the type cert. So right now we are the only company that has a type cert that is open to providing our equipment on the open market. I think a lot of the players are more keeping their equipment to use in their own businesses. So that's the type cert is a significant competitive barrier and is quite defensible. So I'd say that would be a big one. The other key aspect about it is we've been flying, like I said, over cities, BVLOS since 2017, and we've developed a tremendous amount of experience, which we've codified into our operations manuals. And then we've also developed very strong relationships with key regulators over those years, which it's hard to overstate the value of relationships with regulators. And then just the trust that comes from serving these hospital customers reliably and regularly over the years.
All right, we're going to go with our lightning questions, which I have a feeling you're going to answer them briefly as well. So the first one is, if you fast forward 5 or 10 years, Jim, what does the industry look like? And you can define the industry as you would like.
So I would say in 5 years, we're going to see significant consolidation in the industry. The players need to find product market fit and stay solvent while the regulatory hurdles are sorted out. And not all of us will succeed. I think BVLOS in 5 years will have been enabled by rule, at least outside class Bravo, Charlie Delta surface areas. I would say in 5 years, human piloted urban air mobility aircraft will be authorized to fly and carry passengers. 10-year, I would say unmanned autonomous flight will be commonplace by then. And passenger carrying autonomous flight will be in the walk part of the crawl, walk, run phase. Regulation in the US for drones or urban air mobility will have moved past the exception-based part and moved largely into rule-based. Yeah, I mean, 10 years in this industry is that's really hard to predict.
Yeah. So you have a bunch of entrepreneurs and early stage company people on the line right now. What advice would you give to them overall? In starting a business or growing a business, you've already given them great advice on the certification process.
Yeah, so I'd say the key take-home messages from our perspective is, one, don't underestimate the regulatory hurdles and friction. And I talked in more detail previously about why that's important. And then again, hiring is key. Like putting together the right team that has the context of legacy aviation and the expertise there, but also the creativity to come up with new solutions, because that's key in moving forward in a regulatory environment that's still rapidly changing.
What's the most common misconception or misunderstanding when it comes to either drone deliveries or the drone market in general?
That the technology is the hard part.
Well, there's that brief answer.
It is a lightning round, right?
Jim, I got to tell you one other thing they should consider is having somebody like you representing them with the FAA. I got to tell you, we've never met before, but just listening to how you answer questions, you're such a credible person. And knowing a little bit about the FAA, I would assume they would greatly respect not only your background, the technical background, not only the great company that you're representing, but just the way you address things and approach things. It's very disciplined, it's very specific, and there's no hype to it. So I'm sure that helped with your certification process as well. As you wrap up the podcast, how would you want to summarize it for anybody if they approached you and said, "Oh, I heard you did a podcast with the vertical space"? How would you want to summarize it?
Well, I would summarize it in saying that the industry is full of challenges, but it's also full of promise and has a great potential to change the world. And it was fun kind of covering both the challenges and the opportunities in this podcast.
Luca, anything else from you?
No, thank you very much, Jim. This was fantastic. Thanks for a lively discussion and for sharing all of your insights and experiences. Greatly appreciate you being on the show.
My pleasure. Thank you for the opportunity. It's been great talking today.
Thanks, Jim.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.